I welcome everyone to this webinar series for decentralized and sustainable cold storage. We have had a fantastic response and we are expecting participation from different parts of the world and of course across India. Don't know, BAS Research is a small but proud not-for-profit initiative based in Rajasthan. We work in the domain of energy governance, research and policy. A big thank you, of course, to Selco Foundation team, particularly Huda, Rachita, and Kartika for making this happen, especially when it started as a casual conversation less than 3 weeks back. I hope everyone is safe and sound in these testing times. 2020 has definitely been a challenging year. Will it go down as the year of the pandemic or the big turnaround year for human race and our planet is yet to be decided. The images of migrant laborers walking on foot for hundreds and thousands of kilometers is perhaps the most explicit indicator of our failed social and economic systems. The big question is what are the choices we are going to make henceforth, and of course, what are the decisions that are being made for us. The pandemic, while amongst the most testing challenge in recent history, is also shaping into a unique opportunity to initiate action towards inclusion, sustainability, and resilience. In this context, the issue of farmer income and agriculture as a viable trade is a key concern, as 3/5 of our population directly depend on agriculture, but it only contributes less than 18% to the GDP. Inflation-adjusted inflation-adjusted output prices of key grains have more or less remained stagnant in last 20 years, while input prices have been increasingly marginalizing our rural communities. In the wake of COVID, a slew of policy measures to liberalize agri markets have been issued by the Indian government. There is no doubt that agriculture needs to thrive without subsistence and subsidies from the government, as should any industry. But the failure of free markets need to be acknowledged and addressed. Inequity in agri-infrastructure is a good indicator of inequity in free markets. As per a recent article published in Hindu, India's cold storage capacity stands at about 23 million tons against the required capacity of 35 million tons. Most of this, over 40% of this capacity is in the state of Uttar Pradesh alone, and Gujarat and Punjab accounts for another 20%. Majority of this capacity, again, is centered either around trading markets and urban centers, and majority, again, caters only to potato produce. India wastes, as per a UN report, India wastes 40% of its produce, and diesel accounts for estimated 10 to 15% of energy requirements for cold storage operations. Current infrastructure and market designs marginalize the farmers and significantly increase our carbon footprint. A lot needs to be done to address agri crisis, not just in India, but across the world. Access to sustainable agri infrastructure for storage and processing is one piece in the big puzzle. And through this webinar series, we aim to champion innovations and disruptions in the cold storage space, but equally importantly, seed coalitions for collective actions towards just transition. Today, we shall dive into some technology disruptions and product innovations. The second part of the webinar series shall focus on business model innovations to address market and financing barriers. And lastly, the third webinar shall discuss current policy ecosystems, challenges, and way forward to mainstream access to affordable and sustainable infrastructure, especially for small and marginal farmers. Once again, I welcome you all and invite Huda to take the sharings forward. Thank you.
Oh, sorry. Hi, can you hear me now?
Yes, we can.
Yes. Yeah,
over to you, Huda. Thank you.
Thank you so much. Thanks a lot, Simran. I'm just going to see if you can also see my screen. Is my screen visible?
Yes.
Yeah, okay, great. Warm welcome to everyone. Thank you so much, Simran, for setting that extremely apt context in terms of where we are today and why this is so critical to kind of take forward. And I think just the fact that we have people, joining us from different parts of the world with varied interests. I mean, right from enterprises to NGOs to think tanks to governments. I mean, I think just the criticality of this topic and this subject really comes out I mean, of course, if we're trying to reach the SDG goals by 2030, we are going to have to, as Simran mentioned, create these coalitions, these consortiums, these partnerships, these collaborations to really kind of move to a alternate reality, which hopefully post pandemic, during pandemic, we are able to reimagine in a much more innovative and a transformative manner. So, I mean, before the session on technology gets started, just a brief kind of overview on where does this fall within the cooling spectrum. So cooling is not just about agri cold storage technologies, but it's really an entire spectrum, including the small products that we see, the vaccine carriers, the smaller fans, the coolers, and all the way to your space cooling and your pack houses and your health centers, and the need to actually power different institutions as well, right? And given climate change, both from a adaptation and a mitigation perspective, this spectrum becomes very critical, right? And so within this spectrum, whether it's for household well-being, whether it's for agriculture, animal husbandry, work spaces, productive use spaces, which really comes out as especially when you look at states, any state rather, whether you look at disasters in east and northeast, or the heat strokes in central and west India. So cooling kind of becomes a really critical aspect to address in every way possible, right? And specifically, I think this particular webinar and series is focused around cold storage technologies, and these could be, they're not really small scale, but the large scale, the category of the large scale cold storage technologies. But what you see here on the slide is again the spectrum, not from an application perspective, but more from a temperature and capacity perspective, and the kinds of technologies that are available, both active and passive, that need to be combined in most cases to get the most efficient result. So specifically, when coming to what Simran was saying within the agri and the livelihood space, these are more or less what we see as the critical cooling solutions, both from a space and an appliance perspective. Whether it's walk-in agri cold storages for horticulture, floriculture, meat and fish, the smaller retail-based refrigerators, also very critical in the value chain, the vaccine storage for animal husbandry, as well as the dairy sector and the kind of cooling needed there. This particular webinar is focused on the one that you see highlighted there on the cold storage, and specifically focused on horticulture and floriculture. We will be doing follow-up sessions for the different segments. Like we're planning one which is only focused around vaccine cold storages for the Pashu Sakhis and the network of poultry, goatry, and dairy which exists. But this one specifically is a three-part series, as Simran was saying, and we're quite excited about the experts and the practitioners that are coming with the amount of experience and the level of knowledge that they come with. I think it can really help all of us sort of avoid reinventing the wheels and relearning things, which many of us are trying to do in the best ways possible. But I think in each of the series, have been sort of curated experts and knowledge and grassroots level experience that would be represented to actually take some of the learnings and look at what are those enabling conditions that we need to provide specifically to scale the cold storage, and for the horticulture, floriculture, the walk-in agri cold storages, as we call it essentially. This is just a quick side on the ecosystem that we talk about when it comes to cooling. All of these are sort of critical. Cooling in itself, technology in itself is a waste if we don't really look at the finance, the business model, the market linkages, the capacity building, the policy aspects. All of those kind of are conditions without which the technology is really of no use, right? So which is why we've basically divided it into three sessions, and moving forward, you will be hearing from my colleagues slides on the technology disruptions part of it, which will really be focused on why haven't we gone further. Given the opportunity that decentralized cooling and cold storages have, they'll delve a lot more from a technology perspective into that. The webinar too will be, as Simran said, on business models and financial innovations, and specifically on, and both these technology and the business model sessions will provide inputs for our final session on the policy. So warm welcome to everyone for joining us. Thank you so much, and I over to the discussion for today. And we look forward to a very active participation. So we will answer every single question. If we can't, we will certainly sort of connect you with the right stakeholders. So please feel free to type in your questions in the Q&A section, and we look forward to a lively discussion. Thank you.
Thank you so much for that. Thank you so much for that. So thank you for that introduction. And to kick off the first webinar, which is on technology disruptions in cooling, I'd like to request my colleague Kartika to give us like a broad overview on just the different kinds of technologies that do exist, especially when we're looking at decentralization of cold chain. I think that's the main thing that we really want to talk about today. Like, how do we look at disruptions in the cold chain so we are able to look at value add at the last mile? So Kartika, over to you, please. Thank you.
Thank you. So is my screen sharing visible?
Yes, yes.
Yeah. So good evening all. It's well explained why cold storage is essential and how it caters to farm level. I'll just briefly touch upon about the different technologies which are available based on the energy source and the energy storage systems, also the currently available micro cold storage technology providers inside and outside India, and the biogas cold storage. Also, I'll explain the necessity of additional features integrated to the solution, such as remote monitoring and crop management. So to begin with, I'll start with like globally, there are different cold storage units which are powered by different energy sources. The main categories is basically, as you can see, it's a grid, solar and biogas powered cold storages. There are also several research happening around where one of that is a combination of a biomass and a solar powered cold storage. See, as Simran has explained, the current cold storage capacity in India is pegged at 37 to 39 million tons, which are larger units and are quite often located in larger cities and often controlled by middlemen. But there are only a few farm or village level cold storage where uninterrupted power supply is a major challenge for accessing these solutions. In order to fill these gaps, a solar and a biogas powered cold storage, which are on smaller scale, has been emerged. If you can see, the solar powered cold storage technology has been again divided based on the thermal storage and electrochemical storage systems. A thermal storage system is a technology in which the electrical energy is stored in the form of thermal energy by heating or cooling the storage medium. Then the stored energy can be later be used for cooling or heating applications. While using electrochemical energy as a backup, basically it's a battery systems, will not be viable for a cold storage system as the battery size requirement is very high and these batteries have a limited life of 3 to 5 years. And it also can incur an extra conversion loss to convert the stored electrical energy again to thermal energy for cooling. But still, there are manufacturers globally who are using batteries for backup outside India as well efficiently. When you see the thermal storage systems have various applications, like it can application also it reduces carbon dioxide emissions and it also minimizes the energy cost and has the best efficiency among the energy storage systems. Again, the thermal energy storage systems are being divided into three parts, which is sensible, latent heat, and thermochemical. Basically, the thermochemical heat storage systems that technically offers the greatest heat storage capacity and does not suffer from heat loss during the storage period. But the literature on these processes is marginal compared to that on the sensible and latent heat storage materials. The reason is that the research in this field is still in earlier stages. So basically in this webinar, I'll be mostly explaining about the latent heat and the sensible water and the basic difference between that and the advantages and pros and cons of the both.
Sorry, Kartika, sorry to interrupt you, but could we have the full screen, please? It would really help. Thank you so much.
So water remains the most widely used material in sensible heat storage system used for solar energy storage. It is a material that presents the best compromise between the cost, heat storage capacity, density, and environmental impact. You can see in this table, For sensible heat storage, the specific energy is ranging from 10 to 50 kilowatt hour per ton, and the storage efficiency lies between 50 to 90%, whereas for PCM can offer higher storage capacity from 50 to 150 kilowatt hour per ton, and the storage efficiency from 70 to 70 to 90%. Sorry. And numerous PCMs have been developed in the temperature range of 0 to 80 degrees Celsius, which is suitable for lower temperature. Even the PCMs with negative temperature is as well. The advantages of latent heat storage materials on sensible heat material are like it has a high energy storage density and various melting temperatures that allows different levels of use. But the specific heat, if you can see in the table as well, the specific heat and the latent heat of the water is higher than that of the PCM. But another one of the con for the PCM is the life cycle of the PCM, which is around 2000 cycles, which need to be replaced afterwards. Come to the next slides. This shows the different solar powered cold storage providers around India. Most of them have looked at capacities less than 10 metric ton, average of around 5 metric ton, as they are suited to smaller group farmers. But company like Promethean also have looked at 0.5 metric tons, which is not really for agri-cold storage, but for the dairy and to store meat in a smaller scale. And even we have a Statcon Energia who has gone as high as 80 metric tons. The temperature range achievable is almost similar, ranging from 0 to 28 degrees Celsius. But Coolcrop and Inficold have also looked into multi-chambered cold storage model as well. Considering the energy storage system, thermal energy is a storage medium most of them are using, basically PCM. But Inficold is the only provider who is using water, and a lot of them use water, and a lot of them have also used digital platforms in order to for troubleshooting and for remote monitoring by themselves. It can be used by farmers or FPO or cooperatives and by the manufacturer themselves. Few of these also includes crop management. A lot of them are using apps, which I'll cover in the later slides. When you look into the financial models, most of them are sales, but many of them have tried lease model as well. Coolcrop have cooling as service model also. They all are at different stages. If you can see all the number of installations each of them are done, they're all at different stages, and some have worked with FPO farmers, even with government, veterinary hospitals, SHGs, private players, etc. And are mostly the cold storage for storing horticulture products. But Promethean have also looked into storing seafood and meat. So these are the cold storage providers outside India. Even with them, they have looked upon from the capacities with a minimum of 2 metric tons, which is by cold hubs, to a maximum of 120 meter cube area provided by Inspira Farm. Where Inspira Farm, their major work around the pack houses. Most of them uses electrochemical energy for backup, whereas Inspira Farm use water as a thermal backup. And in terms of financial model, if you can see, the coal hubs and Inspira Farm have looked into pay-as-you model, in which also Inspira have asset financing and cooling as service model. Coming to the remote monitoring and crop management systems, many of the technology vendors have integrated remote monitoring and crop management technology to the system additionally. Mainly, the remote monitoring is a common feature used which helps them to remotely monitor the health and the system performance of the unit, which also can support the farmers in a way to tackle any service and maintenance issue related to the cold storage unit remotely. Other advanced features are the crop management or inventory management platform and the market analytics. A crop management helps the farmers to store the produce at the desired temperature, and it also indicates the shelf life of the commodity so that they can plan the storage duration and sell the commodity based on monitoring the fluctuations in the market price. Another feature is a market analytics, which basically has been incorporated in the form of mobile applications, which informs the end user on the expected price for the storage duration of the produce. But also, for better adoption and effectiveness of these technology, a support system is actually required. Coming to a biogas powered cold storage, a biogas powered cold storage is an economically feasible and cheaper solution than a solar powered cold storage. But it requires fuels like animal waste, agriculture waste, husk, straw, paddy in order to generate the biogas. It's also challenged due to the unavailability and high fuel costs in the specific areas where it has been installed. And it requires minimum 60 kgs to maximum 5 metric ton. um, waste treatment per day. New Leaf Dynamics and CanCure are the technology vendors for this technology, where they have a capacity a minimum from 10 metric ton to a maximum of 50 metric cubes. They have also done few installations mainly in the area of horticulture produce, and even New Leaf have implemented more than 40 units across India. And the few of the challenges are high fuel costs, unavailability of fuel, unreliability of electricity, and operationally untrained. Thank you. Over to you, Rajita.
Thank you so much. Thank you so much, Kartika, for that. So once again, welcome everyone, and I'd request my panelists also to please switch on their videos. Yes, I saw a question quickly, and yes, all the information that we're sharing, we will be contacting you after this and sharing these presentations as well as more details of the panelists that you see here. So we wanted to start off by, just a broad introduction. We know that the audience here comes from a technical background or comes from a farming or an agriculture background, policy background. But we wanted to start with like a broad overview to just give you an introduction of what are the different types of technologies that are there and what are the pros and cons. So we have a bit of a context to this discussion as well. And I wouldn't spend too much time, really kind of introducing, who is here, who our panelists are, and I'd let them introduce themselves. So maybe I'll go one by one, but to all our panelists, I'll request you to introduce yourselves in the context of this webinar. So as my colleagues have said before, we are really trying to talk about like disruptions in cold chain. Like how do we really look at decentralizing cold chain and bringing ownership to the last mile farmer, the value add to the last mile farmer. And of course, technology has a big role to play there. So if all of you could introduce yourselves from that perspective, what is the technology that you're looking at? How do you think it can make a change? And what are the kind of end users that you have reached out to so far? But I will limit you to please 2 to 3 minutes because we have a lot to get into, and I'm sure there are loads of questions that will already be coming in. So maybe I'll start with Samit. Samit, if you could go first, please, and then we'll go to the other panelists. Thank you. Samit, yeah.
Thanks, Rachita, and thank you, Simran, and everyone at Selco for organizing this and having me over. To answer your question, Rachita, yeah, cooling is what India needs, and we all know that. Whether it's for comfort cooling at home or whether it's transporting crops or milk or horticulture, animal husbandry, etc., etc. And cooling or heating forms over 70% of the energy consumption. Most of the electricity that we use is towards heating or cooling. And we all know that it's not available 24 hours for various reasons. And that's where we as a company step in, and the technology that we have is used to store the cold or the heat. And as Kartika mentioned, phase change material or even water is where we come in. So we have materials, we have designed materials which can store this heat and cold when it is available in excess or when it's available on the grid. We can store it and then we can use it when it's not available. So that's the angle that we bring into the cold chain. So when you're looking at logistics, when you're looking at distribution, you perhaps may not have access to active systems. Unless it's a refrigerated vehicle, which is, more expensive to run on diesel. So can I do something where I can store electricity in the form of cold in that vehicle and then move around? If I look at biomass, if I look at solar, if I look at wind, if I look at geothermal, it all may not be available at all times. So whenever there is excess energy available, I can store it and I can then use it to give the backup. So most of the companies that you talked about in your previous presentation and some of my panelists here, we kind of work with all those kind of organizations to help them make their cold storages that they're making or the logistics transport systems that they are doing work when energy is not available. And as we go forward, you talked about water as a PCM. That's very true. But that's around 0 degrees Celsius. So when you look at temperatures which are like -10, -20, or you look at +10 or +15, water, as Kartika mentioned, will be working on the sensible heat phenomena, while we would have materials which would work on latent heat, and therefore with smaller volumes of material, you would be able to achieve a larger backup period. And that's essentially what we are doing. And in the last decade or so, we have developed several materials, and we work with several players to help them roll out their end products in this area. Thank you.
So much. Thank you so much, Samit. Kendall, could we have your introduction next?
Yeah. So thank you again for having us. So my name is Kendall Novison. I'm the CTO and co-founder of CoolCrop. CoolCrop focuses as sort of three veins. One is a system integrator, so providing the physical equipment to the farm and on-farm cold storage. A technology developer, where we either use existing sensors or develop our own if they don't meet certain capabilities, as well as agricultural information provider through software and market analytics. So the first vein for us is the physical storage unit itself is modular in size. A module building block is 8 foot by 8 foot by 8 foot, or 2.5 meters by 2.5 meters by 2.5 meters. From there, we can expand the system out. So that allows us to focus anywhere from 3 metric tons all the way up to 30 metric tons in terms of the size of the storage unit that we can provide. We've been able to take off-the-shelf sensors, but where there are limited capabilities on temperature and humidity sensing, as well as CO2 and ethylene, we started to develop our own sensors to integrate into the platform. That way, we can sense more accurately the temperature of the produce itself, so we can better determine, are there ways to reduce energy? And in some cases, we've shown that we can reduce energy consumption by up to 15%. And other ways, we've been able to show that we can either control or expedite the process of ripening of certain fruits, which allows faster throughput and the produce to get to market quicker. And then the last vein has been on agricultural information. So on that side, a farmer will store their produce, but if they don't necessarily know what the price in the market is, or it's unsure what the price is going to do, that's where we have a market analytics platform that pulls about 1,600 different markets across India, and then can provide that price prediction and trends down to the farmer and cooperatives themselves. Our direct customers are the farmers themselves or farmer producer organizations, which are more as a cooperative. And we partner directly with them or with their partner organizations, whether it's NGOs or other entities, to actually deploy the systems. In our case, we wanted a pan-India solution. So we focused on very geographically different areas. So we have projects in Odisha, we have projects in Bihar, Gujarat, as well as Karnataka, and expanding out from there. We also have remote monitoring and diagnostics. That way we can see how this cold storage is performing. Because in agriculture, every hour that it's not within the proper temperature and humidity and other factors is potentially up to a day or two in terms of shelf life lost. So post-harvest loss and the quality of the produce becomes very critical.
Thank you so much. And definitely we'll dive into some of the things that you mentioned in the following questions. But Nitin, maybe we can have you introduce yourself next, and then after that, Akash, please. Nitin, I think you're on mute.
Yeah, hi. Yeah, so sorry. Yeah, so my name is Nitin. I'm the CEO for Inficode. Yeah, so brief introduction. So I'm a grandson of a village vegetable wholesaler. So my youngest remembrance when I was hardly 4-year-old was he bought a lorry full of grapes and everything went bad in 2 days because he didn't have a cold storage. That was way back 1983. So, so as a company, what we do is we provide sustainable cooling solutions in the range of solar milk coolers, solar cold storages, and solar air conditioners. Our solar integration is jointly developed with National Institute of Solar Energy, Government of India. So as a founders, we are cooling scientists. We have 95 patents on our name, primarily into cooling. We have done all form of cooling, starting from converting solar heat to cooling. Your laptops would have more than 10 patents from us. F-35 fighter jet cooling was done by us. We have licensed the cooling hardware for Chotu Cool. Our niche is in understanding the client needs and designing the system as per their needs. Thanks.
Thank you so much, Nitin. And Akash, I think you're on mute as well.
Yes. Hello, everyone. I'm Akash Agarwal, and I co-founded New Leaf in 2012 with Anurag Agarwal. So, cumulatively, we have 43 years of experience in engineering, product development, manufacturing, and sales and marketing. New Leaf is inventor of world's first standalone unit, which is powered by biomass of farm waste. And we have named this product Green Chill. So Green Chill has many applications sector like cold storage, pre-cooling, ripening chambers, ice maker, mushroom growing chamber, dryers, and coolers. So we at New Leaf, we expertise in establishing cold chain at farm and aggregation point to reduce supply chain losses. The Green Chill, being an off-grid and compressor-free, is powered by rice husk, wheat husk, mustard husk, straw, pellets, waste wood, or any kind of crop waste that's available locally at the farm site. So currently, Green Chill is being used for long-term, short-term storage, pre-cooling, and ripening of 10 to 20 metric tons of fruits, vegetables, flowers at the farm and aggregation point before transporting to a market or a processing facility. So this allows farmers to preserve their produce until they get fair prices, and farmers can also store when demand is low or there's a risk of dumping at low prices to avoid spoilage. So our vision is to reach farmer and farmer producer companies to utilize the cold rooms throughout the year using Green Chill and doubling their farm income. So to make this a futuristic product, we have done many interesting upgrades to Green Chill. We have introduced a new product that we call a multi-purpose vehicle, which can dry 400 kgs of perishables in a same cold room facility. So till date, we have installed 40 cold rooms at farm sites and served 1,000 plus metric tons of perishables. Thank you.
Thank you so much, Akash. And we always like to dive right in, and that's why we wanted to keep the introduction short, but leave the rest of the time to really kind of understand what are some of the ways that whether it's Akash done some 40 units, and all of you. What are some of the challenges that are there? We know that when we're talking about decentralizing cold chain, there are issues around awareness, there are issues around like people accepting the technology itself, creating that lead, so to say, or finding that customer who would really help you do the first 10, the first 20, the first 30. But there are equally more challenges when it comes to installation, post installation, the servicing, the supply chain, the technical availability. There are multiple difficulties that will be there. So question to all of you, in terms of, and I would want you to build on each other's, because I know some of the challenges would be quite similar across all these four panelists that we have. So I would request you to not repeat, but maybe build on each other's challenges or provide new challenges. And we'll maybe start with Nitin. Nitin, if you could maybe speak about Inficool's experience, like what are some of the challenges, the one big challenge that you see which would really help you? If that was not there, it will really help you scale your technology. Nitin, sorry, you're on mute again. You're on mute.
Yeah. So I would say that there are multiple challenges. One is education, educating clients. So like lower temperature is not always good.
Right.
That is one, right? There's a limit of extending shelf life, which is and it is commodities dependent. And India doesn't have a lot of data, and any available data is specific to Western world. Then how to store multi-commodity. People talk about, right? In India, the application we see, right, most of the storage is in multi-commodity. So in those cases, right, shall we store at 4, 5, 7, 10, right? So there is another issue. Another issue what we have faced is how to explain the energy requirements. So people will start correlating these cold storages with potato. A potato cold storage will be at 20 times less powerful as compared to a vegetable cold storage. So there's another issues. And then challenges are coming with remote locations and then corresponding mission critical cooling requirements. We have seen a lot of requirement on using zero GWP refrigerants. Unfortunately, those are not available in these remote locations.
Right.
More tech, more failures. There is another challenge we have faced. And then obviously, right, how to quantify impact. Person will be very happy to use it, but he will not be caring about documenting how much he has stored, how much money he has made. There is another issue which we have faced. Then on the financing has been a challenge. Hopefully we will be able to solve it in the next few months. Yeah. So that was my experience on this.
Thank you so much, and loads of points there in terms of, and I know InfiCold has been taking some of those things forward as well on the ground, whether it's in terms of technology change itself or the business model, and we would want to dive into that next. But Kendall, what are your experiences? I'm sure it's very similar in terms of just the awareness, looking at multi-commodity. Of course, it's a seasonal thing as well. Agriculture, the more tech, more failures is definitely something that we would all associate with at the field. But do you have more challenges to add there? I'm sure you do.
Yeah, on ours, definitely Nitin hit it on the head with understanding how cold storage works, especially in the field. We had farmers and farmer cooperatives that, we gave them technology, we gave them the ability to make a lot of changes. And then what we saw is they weren't quite as informed or educated on, what produce needs to be at what temperature. And so we've actually kind of rolled back some of those features, not because we don't trust the farmer or anything like that, but we found other ways to, get about at a better optimization of it. So if we can know what's coming into the cold storage and we know what the proper temperature is, then the farmer doesn't need to know that information or be able to change it right in their user interface. So what we've actually done is roll back features or change what they input. So instead of saying, what is the temperature you want, you now tell us the crop that you want to store, and then we determine what the proper temperature and humidity and other factors are. So it's a way that you can start to drive at what is the best sort of process improvements. We definitely have to go on the farm and educate the farmers. But along with the understanding, we've also had some issues with the banks trying to understand the technology and the value. I remember early on, one of the first projects that we wanted to get financed with the bank, literally the financial institution said, yeah, if you provide us all the upfront capital, we'll loan out your money to the farmer. And then, that way you'll have financing. And it's like, well, hold up. If we have all the upfront capital, we can loan the farmer the money, that we don't necessarily need the financial institution. So, understanding what are the, actual values of the cold storage itself, what can be repurposed, its lifetime and usage, and getting better linkages on the financing side. And we've definitely worked with several partners of improving that. So we're not at that stage anymore, but that was a major challenge up front and one that we still kind of face going forward. In terms of siting, not as much. In terms of first adopters, really hand-holding through that process and saying, we're not just providing you sort of a widget or a product and then going to leave you off in the field to go figure it out. We're there. That's sort of the agricultural information piece where, we're providing them information on the market. They're giving us feedback saying this is beneficial or this isn't, or saying, we would like to do this additional thing here. How do we enable that? So we had one customer that, wanted to go down and sell their excess solar electricity back to the grid. So, we implemented that as an additional value stream and off season. Is it mainly agriculture? No, but it works out as another revenue stream for the FPO. So it's been trying to work within the confines of the FPO and their knowledge, but also expand products and offerings.
Thank you for that. And Akash, coming to you next, maybe you're the only one in the group who, as I said, have been looking at the biomass powered cold storage as well, and the challenges there will be, I assume, the same in many ways, but there will be additional, things that might be there as well. So could you maybe highlight a bit on those aspects specifically?
Yes. So as I mentioned, this is our own patented technology. It's a standalone unit, like a compressor unit. It requires a huge network in terms of providing after sales service and sales, reaching out to the customer, to the last mile customer. So I would say that huge network needs to be provided to service the customer, because unless we provide a 24/7 service, that customer is not happy, farmer is not happy, and farmers, I would say, a season's crop, his whole earning is in that cold room. So if something goes wrong, he has to be serviced within a time frame of an hour or two. So that's the first challenge that we face. The second one is the biomass supply chain. So we have been working on that, and what we foresee for the future is that we have to have a constant supply chain to be maintained for both the farmers and the traders and the farmer producer companies. And if we are able to get that, and definitely the system's operation could get through even the rainy seasons. Thank you.
Thank you, Akash. Samitji, coming to you slightly, and I know that the audience that we have here is of course, we have a lot of participants from India, but we also have a global representation here as well. And my question to you was slightly different in terms of, why do you think technology hasn't scaled, so to say? Like because when you see the structure, so to say, like agriculture and the institutions in India are quite decentralized. So in a way, it should be easy to achieve decentralization here. But what do you see are some of the biggest gaps more broadly?
I think, typically, if I have to pinpoint one reason, I feel it's the cost. Anything new is usually higher priced initially till there is wide market adoption. And that's where the bottleneck remains. It is tough for the farmer because the user group that any one of us is targeting is somebody really at the bottom of the pyramid who doesn't have that kind of money at hand to try and adopt new technologies. And as Nitin pointed out, it's the education level which really is missing. They are not aware of what they can do. It takes quite a bit of convincing. The third aspect, again, why it hasn't panned out is again what was mentioned, that more the tech, more the failures. So how can we make a system easy to use, easy to maintain? Kind of adopt, say, an IKEA model where one can do it by themselves. And that is what we as a company are also trying to look at. Can we create solutions which are which you can give a video, or if you can give some basic instructions and the people themselves can take care of it and try and use it. So these have really kept the technologies from scaling up. When you look at what green chill is all about, there are so many components involved. So anyone, it kind of when it doesn't when the user is not able to understand it, he's hesitant to adopt it. And that's been the biggest I think drawback in terms of new technology. So it takes a while before all of it becomes plug and play and simple and easy to use. And so it's a vicious cycle, I would say, or a catch-22 situation where initially I think a lot of it has to go out free for everyone to test enough to create the right system, to create the right methods which would work. And the other reason is India is a very, very diverse country, right from north to south and east to west. We have different requirements, different languages, different challenges. So a one size fit all model has not been working very easily. And until you can do that, technology will not begin to be accessible or affordable.
Thank you, Samit. And going back to you, Nitin, as well. So you both of you mentioned, for example, that, technology, I mean, I would take it as, technology is not the only answer. It's not that you keep adding features, keep adding apps, and, everything gets solved accordingly. But how have you seen to kind of strike that balance as well? Like, when you look at saying that, some things we can actually improve on our technology, we can kind of start looking at research for. There is a future in terms of what do I innovate on, what am I learning? Versus things that, I need to rely on partnerships. I need to rely on stakeholders, other stakeholders. I need to rely on policy. So how do you really strike that balance? And what are you seeing as some of the features that you have added over a period of time, or you are looking to add now because of the learnings that you've received on the ground, but purely from a technical perspective?
Our stakeholders are our clients. So one of the things which we have noticed is that we need to understand the real need. So for example, in the case of milk need to be cooled only in 2 hours in the morning and 2 hours in the evening. The balance time, compressor sitting idle. So that was the reason why we created instant milk cooler. So we are not only eliminating diesel or coal, electricity, but what we are doing them is we are providing them instant cooling of milk. So basically a compressor will run for longer time. And instead of using a 5 HP compressor, now we can use a 1 HP compressor. We have seen payback of 3 months just because of improving the milk quality. That is one kind of innovation we are doing. Second kind of innovation, what we have started looking into is that India has 3 lakh milk societies. None of them has a milk cooler. So now we are developing a milk cooler which only provide, if you have 6 hours of electricity in a day, we can provide you milk cooling 24/7. And then the next level of innovation which we are doing is developing a 500-liter solar milk cooler at a price of 4 lakh. So as compared to traditional milk coolers, DG backup, payback is hardly 6 months. Then we have started looking into roadside kiosk integrated cold storage units. So like a highway where a farmer can set up his kiosk, which can be his cold storage, and he can also start selling his commodities there. We have installed one off-grid solar air conditioner. We plan to have these kind of so this system for next 20 years, zero recurring cost, and the price point is about 2 times more than a traditional air conditioner. But these are primarily meant for schools, offices, where the cooling need meets your solar availability time. So those are the kind of innovations which we are looking into, primarily focusing towards user needs.
Sure. And Kendall, coming to you, I think you mentioned, when you were introducing Cool Crop as well, of all the different features that you've tried, and I think we'll all agree here that, to a certain extent, the technology is only, as the adoption would be more if there is, income coming out of it, like, and that is a factor of multiple different things, and that's what you were mentioning, whether it's the market knowledge, the market linkage, like, what are you storing, and accordingly, how do you really modify the technology or customize the temperature that is in there. But while it seems like, of course, Cool Crop has been engaging with farmers on the ground directly, changing its language of not changing in terms of technology itself, but changing in terms of produce and commodity and all of those aspects. But what do you think is what do you think is still missing that we don't understand about the end user? Definitely end user awareness is required, is needed. But what do you think is something that we still haven't understood that would help maybe get to a new phase of technology innovation as well?
Yeah, I think one thing that we're starting to dive into is mapping out the value chain of produce and logistics. So, the farmer will say, I want a market linkage. Well, what does that mean compared to an aggregator or middleman saying, I want a market linkage as well? So with the farmer, we've, determined that it's more on, they would like income coming in. They need to know that they have a constant supply, that there's demand there. The middleman or even the end consumer, they're looking at, I want to make sure it's high quality produce. I don't want it to go bad as soon as I get it. It doesn't need to have bruises. It needs to be graded appropriately. And so the same question when asking different stakeholders results at different answers. And so what we're working on is trying to, meld those and what problems each one faces to enable sort of the forward back linkage of sort of the market connection. In our particular case, that's why we're looking at both price trends and what that looks like in a region, as well as, we've got the sort of first mile taken care of and it's in the proper conditions, but what is the next, 100 miles or 100 kilometers to, finally get it to the end consumer? And what does that take? Whether it's, modular cold storage units at a smaller level or transportation, or is it a reliable supply chain, or is it produce tracking and logistics? All are sort of future technologies that we're developing and deploying, and determining what is the value of it as well as what is the cost, because ultimately the value has to be more than the cost, otherwise it won't get deployed, or it definitely won't expand in scale.
Right. No, definitely agreed. And Akash, coming to you next as well. Do you agree in terms of when you add these features, is it actually useful on the ground? Like, you add these different apps, you add troubleshooting, you add kind of, features around, market pricing, all of those aspects, but is it actually usable on the ground? Or is this more training, more awareness? Is technology the right way to address it?
Yes, definitely. Technology is the right way to address it, but you have to teach the user how to use it. So you have to provide the hand-holding support to make him use it, to make him or her use it. And to do that, you have to firstly make sure that the unit is on.
Right.
It stays on 365 days.
Right.
And unless it is being used 365 days, the farmer is not going to make money. So the main point is the utilization of the unit. So the basic, I would say, reactor has different uses. We have to have a system, a cold room having different uses, so that can be utilized throughout the year. And then it serves the purpose, and then attaching technology part to it, providing reference points to the farmer, to the buyer, to the seller of the perishables. It makes sense. But before that, firstly, keeping the unit on, and secondly, training the farmer. There's the two main things that needs to be done.
And Samitji, coming to you, I mean, we always see Plus as someone who is really behind, like, one of the base technologies. Like, you're looking at the phase change material itself, and of course that kind of changes the efficiency game quite a bit. Changes the affordability game quite a bit as well. And for us, like, technology has a huge role to play in that, in really putting that benchmark of pricing, benchmark of efficiency, which will bring down the cost quite a bit, the recurring costs, the battery costs, the solar costs. And is there something that you see from that side? Like, is there more that can be done in terms of future of innovation in PCM or storage, or, any that kind of, what are you working on right now in Plus?
Yes, a lot can be done. Water is the best PCM. We know it. PCM, just to get everyone on the same page, is changing phase from solid to liquid. So water becomes ice. You store the cold, and you're able to use it at a later time. So you can freeze water, you get ice, and you put it into your glass of water again, and the water becomes cold. So that's what a PCM is. You can keep freezing it over and over again. But that, as I mentioned, was at 0 degrees Celsius. So when you look at a lot of other temperature ranges, like, you're looking at -10, or you're looking at -20, or +5 or +10, you generally tend to have synthetic phase change materials. That is, you design a phase change material, and water has been working for millions of years, and no problem. So with these PCMs, you need to increase their life. So typically what we make today, maybe with a life of 10 years or 12 years, can I extend it further? So second, what we are also looking at is the conductivity of these materials. Can I conduct the heat or the cold faster or in a better way? can I reduce the time needed to freeze this, or can I increase the capacity of these materials to store the heat or the cold? So those are the kind of things we are working on. And the other thing which challenges people when they use such liquid solid phase change materials is what if something punctures and it leaks? So one of the innovations that we are doing is we are modifying these materials to make it so viscous that even if it punctures, it will not come out. So it's going to be like a solid to solid phase change and still have it. And that allows us to also integrate it into the wall. So if you have the, if you look at the EcoZen model, for example, where they have the insulated PU foam structure and they line the PCM plates on the side, can those PCMs be integrated into the PU foam itself? So it becomes a de facto thing that you have phase change material present in your structure, which is absorbing the excess energy that is there and storing it. So that would make it easier. The user would not have to deal with one more component. It's there as part of the whole system that he is getting. So that's one thing that we're looking at. And also phase change materials tend to improve energy efficiency substantially. It reduces the the cutting in and cutting out of the compressor, which is there in any cooling system, because you kind of have the thermal mass stored in. So, more easily retrofittable options, because if I look at 5 years down the line, perhaps there's going to be enough renewable energy or enough electricity already available if things go the way the government wants it to, that there is enough electricity there. So when that is there, you will look at saving costs. When is electricity cheaper? If it's cheaper at night, can I run excessive cooling at night, store it, and use it at the daytime? So that's what we do in buildings, for example. So that gets enabled, and those are the kind of things we are looking at. And so I think there's still a long way to go in making. Materials have always formed. Whether it was plastics when it came in, it was a boon. Now it's a bane. So we have to look at different ways of ensuring sustainability with these materials, with their disposal. So all of that is there.
Thank you so much, Samit. And I'm going to start taking some questions. We have a number of questions coming in, and one of them is very related to maybe some of the things that you covered. So I'm just going to feed that in right away. So Samitji, maybe this is specifically for you. So are there any ecological benefits of using water as a PCM over other PCMs, considering temperature use is for horticulture? Is there any ecological damage involved in manufacturing of other PCMs?
Not really, because when you look at PCMs, they are essentially 80% water. It's only the balance 10 or 20% which are salts which go in, and these salts also come in a way from the earth. So the common salts which we all are aware of, for example, sodium chloride or the common salt. Now, so that depresses the freezing point of water. So when you take a glass of water and add a teaspoon of salt, you are lowering the freezing point. So that's typically how PCMs are made. So ecologically, it's not really a challenge in terms of disposing it off, for example, because they're salts. But yes, any chemical is harmful in some way or the other, especially if it's in excess. So you do need to follow standard environmental regulations of the local authority to ensure that you've disposed it off correctly. At the same time, there are a lot of companies around the world which look at organic phase change materials. So that's coming in. So there are derivatives of, for example, palm oil or even coconut oil, for example. So there are different plant-based derivatives which are being used today to create phase change materials. So it's not really a big challenge in terms of ecological damage that one is looking at, but yeah, one.
Thank you. And the next question, I think more for Kendall and Nitin. So I'm going to combine two questions because I feel they're very similar. So one is, what are the common challenges of multi-commodity cold storage operation? And the second is, how does automation in temperature adjust for multiple commodities being stored? Is there a way to ensure only similar temperature commodities are kept at a time? Either of you or both of you, if you would want to take the question.
Yeah, I can start. So we do have a database of different agricultural produce that we're able to look at the compatibility of storing them together. So one example of two things that shouldn't be stored together are onions and potatoes. Due to how they naturally respire and their ethylene production, as well as other outgassing, those two do not work well together. Part of that is just from academic research as well as on the ground research that we've done. So you can't do every single commodity with every other piece of commodity, but there are general overlaps. So if we look at sort of the top 5 crops in India, we have onion, we've got potato, we've got cauliflower, ladyfinger, and brinjal. Some of those can actually be stored with others. Is it the most optimal temperature or humidity for each one? No, but it's very close on similar varieties that you can actually do some multi-commodity inside the same chamber, or even section off or partition inside the chamber itself to allow for different produce and different temperature and humidity, as well as other factors to be controlled for.
Nitin, anything from your side to add?
Yeah, so one is, so as Kendall has mentioned about, so don't store ethylene generating commodities like apple. That is one challenge. Second is chilling injury. So a lot of commodities like banana is prone to chilling injury, dry. Then green chilies is prone to chilling injury. So don't store them at lower temperature. If the requirement is for short-term cold storage, then I believe multi-commodity cold storage is more like a fridge at home. Set it up at 7 to 10 degrees Celsius. It will be good for most of the applications. And if you are storing apples, then store it wrap it up in a box. Now, if you want to create a multi-temperature cold storage, the only challenge is that now you need 2 cooling sources. So once you have 2 cooling sources, then they can be bifurcated with a sheet, with a puff panel, or a plastic sheet. Those are the possibilities. We have started providing 2 chamber cold storage units now. So those are the typical ways we can do it.
Sure. Akash, there is a question for you as well, and I'll take that next. It says, do biomass-based systems require more maintenance, and is waste handling also an added challenge from your experience in implementation?
So since last 3 years, what we have seen, these green chill cold rooms owned by farmers, installed at farm site and powered by farm waste. And up till now, what we have seen that we need one service engineer for servicing 5 units. And till date, we have not charged AMC to the farmers just because there's not any cost related to the maintenance. So second part is the biomass supply chain. Yeah, there is an issue, there is a challenge with the biomass supply chain, and specifically in the rainy season. In certain parts of the country like Assam, now Gujarat also receives a lot of rain. So what we for the customer we provide a supply chain, and we make sure the cost at which a farmer was procuring the biomass, we provide the biomass at the same cost. And the third thing is the biomass is very small. So in case a farmer having 5 acres of land, of agri land, that is, then it is self-sufficient to run green chill for 365 days. So typically, when you load the produce, which is the daily loading capacity of 5 metric tons, the biomass consumption is between 70 to 80 kgs, and you would use any kind of biomass without processing it. It could be in powder form, it could be in solid form, or it could be even biogas. Once the produce reaches the desired temperature, which could be between -2 to +25 degrees Celsius, the consumption of biomass will drop down below 50%. So, which means the average consumption comes out to be 40 to 45 kgs in a day. And that is very easy to procure at the farm site.
There are a few questions here which really are, I think, pointing towards the utilization of the cold storages, and I just wanted any of the panelists here to answer that. Like, is utilization a problem or an issue when it comes to implementation on the ground? And the second is a bit more in terms of there are a bunch of questions coming around cost benefit analysis, or what have you seen as so to say the break-even points. At what point of time does something like a 5 metric ton cold storage unit start to make sense? So if any one of you would want to cover that, thinking of maybe a specific case that you have in mind, then
Yeah, I would like to take that up. Yeah. So in terms of, as I mentioned, keeping the unit on, that is very important. And that is only possible if there is multi-purpose use of that cold room. Designed green chill in such a way that it has multiple applications. If a farmer or farm producer company is looking at a short term and long term storage, he can do it. If he's looking at ripening, it's possible. He can ripen 5 to 15 metric tons in one go. If the need is pre-cooling, then 5 metric tons can be pre-cooled within 8 hours. So we have added one more benefit, one more application to the same room is of drying. So if there are fruits, vegetables, or herbs that need to be dried the same day, then a farmer in uh, in a batch of 200 kgs, which can be dried within 5 hours time frame, can dry it, and that increases the value from, so like example of neem leaves. The price of neem leaf, like by plucking it from the tree, is just 40 paisa kg. And once you dry it in 5 hours, the value increases to 25 rupees a kg. So that's a whole lot increase in the value. And in terms of the cost benefit analysis, what we have done is that we have taken clusters, and those clusters are for high value crops. So specifically, it could be orange, pomegranate, guava, apple, pear, watermelon, muskmelon, and we make a business model for a farmer around that crop, so that even if the farmer is storing that crop, specifically I would say orange, for 2 seasons. So what the first season that comes in is in the harvesting is in February, and the price in March for that orange is just 20 to 25 rupees a kg. And if you're able to store orange till last week of April or first week of May, then the farmer can easily get double the price of 40 to 50 rupees a kg. So that's a huge benefit, but you have to make sure that it has to be designed keeping in mind what goes into the cold room. Thank you.
We also have with us, thank you so much, Ram sir, for joining. He's definitely an old friend of Salco and an expert in specifically microhydro, from a microhydro perspective. And he sent a quick question, if one of you could answer, please. That do the produce need any kind of pre-treatment, for example, thorough washing before they could go into the cold storage units itself? Any kind of pre-treatment that needs to be kept in mind before you really store into the cold storage?
So I can answer. So definitely there should not be any bugs, mud over it. Some sort of cleaning some water washing is required, but it need to be also drained. So that water over that vegetables can cause rotting of vegetable.
Right.
So a little bit of removing of dirt, bugs, and then cleaning it with water. But like few applications like lemon would require a wrapping up with wax. Apple might require wrapping up with wax. So those are right now like more fruit specific applications.
And just to add here, Rachita, so what Nitin mentioned, for example, wrapping up with wax or other things, you're trying to prevent certain gases from getting in or getting out.
Right.
And when we're looking at decentralized systems and what all of us here mostly are doing, we would like to differentiate between a cold room and a cold storage. So you're looking at a day or 2 or 3. It's essentially a fridge at the doorstep of the farmer, and not a cold storage which would allow him to store the apple for 2 years and then send it out. So the kiwis or the apples that you're getting all the way from New Zealand and Australia these days are probably a year or 2 years old also.
Mhm.
So when we talk of this, it's very important to realize that we're talking of a short-term cold room solution rather than a long-term cold storage. So when India talks of cold storage, as somebody mentioned right in the beginning, we are always linking it to potatoes. So we have enough cold storages for potatoes.
Right.
But when we come to horticulture, fruit, fresh fruits and vegetables, that's where the challenge is. And typically those, again, it's a user perspective or illiteracy, you may say. People don't like to buy things which are cold, for example. And there are stories that you hear about, you take it out from the cold room and you kind of put it in warm water and then you sell it so that it doesn't feel that it's,
Mhm.
so it's important to distinguish between a cold room and a cold storage and what you're looking at. And the payback period would, as Akash mentioned, would vary depending on the product that is being stored. And when you're looking at the small farmer who wants the decentralized systems, you also need to ensure that there are these clusters or these user groups formed, so that if you have a small land holding and you have a product which is say January, February, March, somebody else is able to use it in April, May, and June. So those kind of systems need to be done, and that has always been a challenge in India in terms of trying to aggregate people and getting them to work together and have a co-ownership for something.
I'd like to add to that as well. We've seen that when you put down the physical equipment, the adoption and utilization has kind of a low pass filter or a lag time to it. So it may be that they only store, if it's 5 metric tons as the size, they maybe only store 100 kgs or 1 quintal, and then a couple weeks later they get more comfortable with it, and that slowly increases over time. But there is a lag period to adoption, even if they have produce available, to trusting it, and then once they get more comfortable, then that increases. And we do business models on the crop itself, the price that you can get, as well as price variability, because that can impact, along with utilization, what the payback or break-even point is.
And Nitinji, maybe this could be for you as well. But are there any lessons to be learned from the traditional cold storages that have been there before this as well? Or is there some case studies that you can talk about from a technology perspective in a particular geography, which you can think of as to there is a lot to learn from within India, outside India, done by Inficold or any other provider as well?
So I would say, right, lessons learned from the way potato is stored. Apples are stored, right? This is right in India. If we look into supply chain of milk, so the only reason India gets milk in summer is because the milk in winters get converted into powder. So those are the ways, right? So, and the same is the way for getting apples. There were a few case studies which I remember. I think vaguely remember there was a case study where quinoa from Himachal was shipped, was transported to Bangalore in a PCM based truck. So those are the possible ways.
Would anyone like to add on any lessons from traditional cold storages that might be there? Any cases that you can think of which are for you the ideal technology implementations and learnings from there, which the speakers should, the participants should take forward as we go towards the last 15 minutes of this webinar?
I think, yeah. So there are many cold storages, and now traditional cold storages, and now they have been converted into multi-commodity. Specifically, a multi-commodity cold storage needs smaller spaces of 10 metric tons, 15 metric tons, and 20 metric tons. The types of crops that are going in are high in value, and it cannot be mixed and matched with the potatoes or onions or any other imli kept in the same room. So the way forward, I would say, is the smaller cold storages, sorting and grading of the high value crops into different chambers is the way.
I just wanted to, we were all, as I think Simran had set the context from the beginning as well. We're in a time of pandemic, and there was this whole understanding of. It was at a time when it was the harvest time. We'd heard about a lot of wastage that happened, and people have been really kind of looking at decentralization right now of infrastructure, agri infrastructure in general. And just wanted to again hear all your thoughts on in terms of like how would you want to utilize this time. We always like to see a silver lining in any kind of disaster as well. Like how can we really make learn lessons here and go towards a kind of a better future, more decentralized future. And just as a kind of closing remarks from all of you, in terms of like who are those private stakeholders, what are the learnings right now, who are those private stakeholders, government stakeholders, what are the programs right now that we would really want to influence, which could help all of you and your colleagues as well, to scale innovation, scale development, scale manufacturing, which would really help all of you create that whole grounding that you need to be able to disrupt the cold chain right now. So maybe I'll start with Kendall and then go after that to Akash, Nitin, and Samitji.
So I think the future improvements that can be done are on the financing side as well as additional policy side. So one thing that we experienced was when putting together sort of a portfolio of projects and submitting it to the government agencies, is it didn't quite fit within their traditional models of the larger cold storages that were more centralized. And it took a little bit of convincing and understanding, what the differences are, as well as the value adds to it. So having policies that, also focus on a broader range of sizes as well as what it can do, and really allowing those to enter existing programs, because there are a fair number out there, but they may not necessarily work exactly for your application. They have to be tailored or modified. And it's really a willingness from different organizations politically to do that. We are seeing more traction, which is good. It's definitely much better than it was, 2 or 3 years ago, but we're still, not quite there. And same on the financing side, and there'll be another webinar on this later that I'm curious to see. But around adapting some of the risk and understanding what the aspects are, so we don't have, like in our first case, where the company had to give the bank all the money up front to even loan it out, which shouldn't be the case. There needs to be shared risk taking in that regard. Is it 100% risky? No, but understanding what the risks are. So I think those would really help enable the technology to move forward. Always there will be improvements on technology as we go forward based off of customer demands or problems that arise. That won't stop. But the other aspects definitely could help out and be a gain or amplification of adoption. In the case of COVID, what we were glad to see is we had additional farmers reach out to us directly and say, we would like cold storage here because all our crop was wasted. We weren't able to sell it in the market. And, there's some crops that we can't store for 2 years, apples, potatoes, things of that can, but there are other crops that can't store that long, but they can be stored longer than where they're currently at. And so that adds value into, smoothing out price variabilities, as well as being able to get produce where it needs to be in a timely manner.
Thanks, Kendall. Akash, same question for you in terms of like, who do we want to influence? Who do we want to speak to that can really help ramp up the the implementation, the development, the manufacturing, the innovation on cold chain?
So I would say the new scheme that has come up is the Agriculture and Infrastructure Fund, and if this scheme takes up, then definitely that will provide a lot of leverage in terms of financing at cheaper cost, at cheaper price. So I think the financing is a big worry, because when someone needs something, there needs to be financing at that point of time, like buying a car. If we buy a car, we get a finance within a day, but it's not the same in terms of agriculture. If we need finance for a cold room, it might take a month, or it might be done in the next season of crop, and then the farmer doesn't feel the need. So I think that finance part needs to be worked out. And second is the COVID crisis, and this crisis have taught a lessons to both us as a manufacturer and to the user. So we have to make sure that the community is being benefited. At wherever the installation is, it should not be a single owner. It has to help the neighboring farmers, and when it helps the neighboring farmers, the word spreads around. We build entrepreneurs, the farmers learn about post harvest management techniques. So that is how we teach to the rural masses. Yes.
Nitin?
Yep. So during this COVID time, we have been focusing more on policy side. So as you know, you might be aware, India doesn't have any testing standards for solar cold storage units. So we have been working very closely with the stakeholders on formalizing the testing standards, and along with all the solar cold storage manufacturers. So we are hoping that in a month there will be a testing standard published by MNRE. Another is that the Ministry of Agriculture based subsidies and policies are primarily focused towards large size cold storage units. For small size cold storage units, one state will tell that NHM will allow 33%, another state will tell no, it will not allow. So there's a lot of confusion behind it, and we have been trying to get the real answer on it. Apart from that, another funny thing is that in India, there's a lot of subsidy on electrical vehicles. It is still it is right energy storage, right, powered through a lithium ion, which is definitely more dangerous in terms of manufacturing as compared to PCMs. I would like to see some kind of policies from government where PCMs are promoted similar to electrical vehicles. Same is the case in milk cooling industry, where right now in India subsidy is given on diesel generator, not for PCM based milk coolers. So India would require a lot of policy change on those.
Thank you so much, Nitin. And Samit.
Yeah. So I think it's important when you talk of stakeholders, it is important to look at the complete ecosystem. You know, when you talk of you are speaking to the Ministry of Agriculture, you're speaking to the Ministry of New and Renewable Energy, you're speaking to the Ministry of Food Processing Industries, you're looking at skill development, you're looking at even Environment Ministry, for example, if you're using biomass or other solar things. So all these ministries need to first get their act together and have just one policy where innovators can simply go to one, and if it is accepted by one ministry, the others should kind of just accept it, because you trust your fellow workers in a way, and not try and duplicate a lot of work for everyone. And as Akash pointed out, transparency is needed significantly in terms of doling out subsidies. They have to be online. With IT available today, there should not be any human interface, and until that goes away, farmers will not come forward to buy something which is expensive, and they know that they may not get the subsidy, or for that matter, the manufacturer may not get the subsidy, depending on whom it's being given to. And to address the other thing on standards, and also what Nitin mentioned, that you're giving subsidies for, or there are policies in place for electric vehicles, etc. Until the technology, until there are many technology players and larger ones also that begin to look at it, getting the government to act is always a challenge, because the smaller organizations will not have that kind of a wherewithal to try and move the machinery and have policies in place for newer technologies.
Thank you, Samit. And I see we have still a few more minutes, so I want to just maybe get in one more last round of question, or just like a last statement as we again close in. As I said earlier, like we have some we got some questions from the Northeast as well, where they were saying in a hilly region, like how do we look at distribution there? How do we look at maintenance and servicing there? And similarly, we have audience here from Africa, from Philippines, and I just wanted to maybe get just one round of one statement from all of you in terms of do not make this mistake. So if there is anything from you as technology developers, providers, who've been really looking at disrupting and kind of looking at decentralization, working with small and marginal farmers, what is the one key lesson that you would want the participants here to take away, saying that do not learn this from me, do not make this mistake? Kendall, can we start with you?
I think the one lesson that we learned the hard way, but earlier on, is if you work with partners, definitely test their quality, definitely test the product wholly if there's something that you don't control in that process, and test often, because we had one supplier that we tested up front, worked great, got it into the field, and was not what we originally had. So on that one, we ended up bringing it more in-house for quality assurance and control. But yeah, do that early, do it often, and you can't do it enough.
Sure. Akash?
Say don't commit anything upfront. And secondly, check the energy that you have. So whatever is abundant, it might be solar, it might be biomass, it might be grid power. Use that source energy to power the cold room, to power the decentralized cold room. So check what is local to you.
Samitji?
Yeah, so I think it's the user, when he's when he's choosing the technology, he needs to understand it well, so that he can, when you're looking at remote areas like Northeast or remote parts in Africa, there will not be easy access to repair, maintenance, and constant support from the supplier perhaps. So understand what you are buying, understand what your requirements are. Do not just go in for a cold room because it's the in thing to do. If you need it, how are you going to use it will then depend on that. So,
and Nitinji?
Yeah, so one is make sure there is a road on which the cold storage can travel. We have seen this issue multiple times in Northeast. Road is small and system is big. This is one. Second is we have done a lot of non-solar but PCM based solutions. Make sure you have proper earthing, voltage stabilizer. We have done few installations in Sikkim. Every 1 month we were traveling there to repair the system. We paid our own money to put earthing and stabilizer. Nothing happened later. So these are the power quality and road quality.
So thank you so much for all our speakers here, to everyone who joined the seminar. Just to there were a lot of things that we discussed here. We really kind of tried to narrow it down to discussions on technology only in this webinar. But all of these, from Nitin, Akash, Kendall, Samit, they all have a lot of obviously inputs in terms of policies, which we already heard, which we will be looking at in webinar 3. And in webinar 2, where we will specifically be discussing on financing and ownership model. I think we touched on it. I think all of them to a certain extent said that is one of the challenging pieces. That is something that needs to be looked at. And in the next webinar, we will be really kind of honing down on that. All of the people that you are listening to right now, case studies from there, things that they have, programs that they have tapped into, how they have unlocked financing. That is something that we will try to represent in the next webinar. But in addition to that, we will have some more ground players to discuss more on financing and ownership models. So we will have Mr. Vedant Katiyar from Dehat, who is based out of Bihar. Again, looking at where the need lies and how do we really look at operationalizing this technology, from that installation to post installation, really try and get the value of the value to the farmer. What does it take to do that? We will have Jitumoni Kalita, who's from Gram Vikas Mancha, who will be joining us from Assam. We'll have Garima Kumari, Ms. Garima Kumari, who will be talking about her experience in Jharkhand with Cine. And we will also have 2 tech providers who have actually looked at, looking at their business model and financial model in different ways, so the ownership can be decentralized. And that would be Mr. Devendra Gupta from Ecozen and Mr. Jofi Joseph from Promethean. The session would be moderated by my colleague Huda from Salco, and we will be doing that next Friday, 28th. So loads of, I feel, some threads have been closed, some threads are yet to be closed, and that will be done in webinar 2 and webinar 3. So please do join. And we will be following up. I saw a lot of questions, any presentation that we made, plus additional information on InfiCold, on Cool Crop, on Plus, and on New Leaf will also be shared with you. So please feel free to reach out to us, and we'll be happy to make any connects at all. And please feel free to reach out to them individually as well if you have any questions. We will be making a note of all the questions that are left unanswered, and we'll try and get back to that as well. So thank you so much again to all our panelists, to everyone who joined. Thank you so much for a lovely discussion, and we'll see you next week on Friday at 5:30 India time, and hopefully more people this time. So thank you so much again, and have a good day. Bye.
Thank you.
Thank you for having us.
Thank you.